Hey everyone, welcome to 3.2 for pre-algebra. We're talking about solving equations that have like terms in them and parentheses. Okay, so let's just kind of start off with this problem. If I had 3n minus 40 plus 2n equals 15, and I said let's solve that. How do you think we'd do that? Well, here is where we are going to encounter having to understand what it means to have like terms. Okay, like terms. So on this side of the equation, do I have any like terms? Well, what's a like term? Well, if you remember, a like term would be like 2 and 4 are like terms. But also 2x and 4x are like terms. So like terms are two numbers or terms that either don't have any variables, or if they do have variables, they share the same variable, such as these two right here, 3n and 2n. So if I were to combine 3n and 2n, and they're both positive, he doesn't have a positive sign, but I can write it in if I want. It's like saying 3, something that starts with n. Why am I drawing a blank? 3 numbers plus 2 numbers equals what? Well, that would get you 5 numbers. Now we still have this minus 40, and it equals 15. All right, but what we've just done is combine like terms to get us closer to solving, because now I know that I got to get rid of a minus 40, and I have to get rid of a multiplication of 5. How do I do that? Well, again, I do the addition or subtraction first. How do I make negative 40 0, or just make it go away? I have to add 40 to it. But if I have to do, if I do that to one side, I have to do it to the other. So I'm left with 5n. Those cancel, equals 55. All right, so the last step would be, well, 5 is being multiplied by n. I need n to be by itself and look like that, so we've got to get rid of that 5 by dividing by 5, and those either cancel, or you could say they become 1 and 1. And if you did that, that would be 1n over 1, which is just the same as saying n anyway. So that's how we get that. And if I divide that side by 5, I have to divide that side by 5. 55 divided by 5, 11. And there's your answer. So that's the nuts and bolts of how you solve an equation that has some like terms. So why don't you guys pause the video, and I want you to try this one. Alright, so once you try this one, I want you to pause the video, try solving that one. So you're solving for the variable x. Play it when you're done, see what you get. Alright, so I would look at this and say, oh, you know what? I have some like terms. And before I start really getting into the nuts and bolts of solving, I need to make sure I combine all the like terms I can first on each individual side of the equal sign. So I have a 3 there and a 12 there, and I know I can combine those to get 15. So I'll be left with 2x plus 15 equals 27. Now I know that I have a plus 15, got to get rid of him, got to also get rid of a times 2. So we'll get rid of the 15 by subtracting 15 from both sides. Again, we do that because we're solving an equation and we're keeping everything equal. So I have 2x, those cancel or become 0. That equals 27 minus 15. Well, what does that get you? It gets you 12. And so then if you were to solve this the rest of the way, what would you do? Well, you divide by 2, you get x to equal 6, and you'd be done. All right, before we move on to the next one, I just realized I didn't number the problem, so let's go back, and this guy would be number 1. This one would be number 2. And now we're on to number 3. All right, anyway. Okay, so 4x plus 2x minus 12 equals 3 plus 15. And if I said solve it, what do you think you'd do? Well, hopefully you'd say, all right, gotta see if there's any like terms, okay? And when I mean see if there's like terms, I mean see, hey, are there any like terms on this side? And then, hey, are there any like terms on this side? Okay, so we're going to combine like terms that are on the left, and then separately that are on the right, and then move forward. So I have like terms there. I got a 4x and a 2x. That would give me a 6x, because I'm adding 4x to 2x. Then I subtract 12, and I make that equal to, well, I have a 3 and a 15 there. That equals 18. Okay, now we're just kind of doing what we know how to do now. I'm going to get rid of the minus 12 by adding 12 to both sides first. I'm left with 6x cancels equals 30. divide by 6, divide by 6, 30 divided by 6 gets you x to equal 5. Now, how can I be sure I did it correctly? Remember, we can always go back and plug our answer into the original. So let's plug the 5 back in there for that x and for that x and see what we get. So if I rewrote it, it'd be like saying 4 times 5 plus 2 times 5 minus 12 equals 3 plus 15. Hopefully you can see all that. All right, so that would give me 20 plus 10 minus 12 equals 18. Order of operations, got to do the addition first. Okay, we're going from left to right, even though addition and subtraction are kind of like, on the same playing field for order of operations, got to move left to right. 20 and 10 gets you 30, minus the 12 equals 18. And again, little question marks here because we're just testing to see if we did it correct. I'm not saying it is equal yet. Well, 30 minus 12 actually is 18, and 18 equals 18. So our answer checks out. Therefore, x equals 5 is the correct answer. All right, but what if you had something like this? Negative 21 equals, that's a bad equal sign, equals 7 times 3 minus x. Well, what I want you to see is that when we have parentheses, we have the opportunity to use the distributive property. And again, the goal of solving any equation is to get the variable by himself. Okay, so he's on the right side of this equation. That's totally okay. So I want, in the end, I need it to look like that. X, some number equals x. All right. Now, I want you to think of parentheses like prisons. And I want you to think of the things inside the prisons as innocent. Okay, so we're trying to break the innocent things out of prison. And the way we do that is not by using tactful lawyers. We use distributive property in math. So I'm going to distribute the 7 to the 3, which is going to get me, I'm going to rewrite my negative 21 equals 7 times 3 is 21. And then 7 times negative x, make sure you keep that sign, 7 times negative x. Well, that's like saying 7 times negative x is really the same as negative 1x. I could rewrite that as negative 1. So 7 times negative 1 times x, if that helps you. And 7 times negative 1 gets you negative 7 times x. And if you were to rewrite that one more time, you get negative 7x. Okay, so that's the long, lengthy way of breaking that down. But if you just want to look at 7 times negative x and say it's negative 7x, hey, that's fine. All right, so what do you do now? Well, we're kind of at the point we've been at for a couple days now, and that got to get rid of a 21, and it's a positive 21. Got to get rid of this negative 7 times the x. So again, we deal with adding and subtracting the constant terms first. So which is my constant term here? This guy, all right? I want to get rid of that 21 by subtracting 21. Got to subtract from both sides, though. So negative 21 minus 21, well, let's see, that's like adding them, which would be 42, and then slapping on a negative sign, so negative 42 equals, those cancel, negative 7x. All right, last step is just to divide by negative 7, because negative 7 is being multiplied by x, so we do the inverse operation, divide by negative 7. All right, negative divided by negative is definitely going to be a positive, so what's 42 divided by 7? You get 6. And there is your answer. 6 equals x, or you could write it as x equals 6. Either way is okay. This is preferred. All right, so I want you to take a second, and I want you to try this one on your own. Pause the video, try it, play it when you're done. See if you get the correct answer. All right, so I hope what you saw was parentheses and thought prisons, okay? You got to break this stuff out of the prison because they're innocent. This x minus 1 is innocent. And how do you do that? Well, again, you have to use distributive property, okay? And that says I got to distribute what's outside the parentheses to what's inside. Now, the question is, what is outside the parentheses? And here's how I want you to think of this, all right? We have our 5x, all right? We're not going to touch him yet, all right? But now I have a minus 2, but I want you to think of it as a negative 2, okay? So we're going to distribute the negative 2 to the x first. Negative 2 times x. Well, that's like saying, I'll do this on the side here. Negative 2 times x is the same as saying negative 2 times 1x, because x and 1x are the same. And I can break that up even further by saying negative 2 times 1 times x, because we know between this 1 and that x there's multiplication. Negative 2 times 1 is negative 2. Bring down our times x, and I can simplify that one step further by just saying negative 2 times x is the same as saying negative 2x. So when you distribute the negative 2 to the x, you get negative 2x. All right, what's next? Well, got to distribute the negative 2 to the negative 1. Okay, and that means negative 2 times negative 1, which of course is positive 2. And that all equals 8. So now what do you have the opportunity to do? Well, I see some like terms here that we can combine. 5x and a negative 2x, or you could think of it as 5x minus 2x. Well, that's of course going to get you 3x plus 2 equals 8. Okay, now we have to subtract 2 first from both sides, which leaves me with 3x. Those cancel, equals 8 minus 2 is 6. Last step, get the x by itself. He's being multiplied by 3, so we got to divide by 3, which will cancel those or turn them both into 1s either way. And divide by 3, you get x equals 2. And there you have it. All right, so hopefully most of you guys got that one. I have full confidence in your ability to tackle problems like this. All right, so being able to solve equations is obviously really, really important, but we want to know how to formulate and use equations. Okay, so we're going to do one last problem. And what we're going to say is that, all right, so we have this problem here. Okay, you're on the cross-country team, and you're running a race, hopefully not getting hit by geese. And if you run 1 mile per hour faster than your current speed, you can finish the race 3 miles. Oh, no, it shouldn't. The last 3 miles of the race in a half hour. I'm sorry, that is the way it should be. So what's your current speed? Well, I'm going to give us a little bit of a kind of little bit of help in that we're going to use a specific formula. We're going to use the distance formula. And distance formula is this. D equals RT. Now what does that mean? Well, D is distance, R is rate, T is time, and RT of course means R times T. Okay, distance equals rate times time. So the question is, what are we finding and what do we know? Well, what we want to find is your current speed, right? Okay, well, do we know your current speed? No, so we're going to put current speed as the variable x because we don't know it. All right, now what about a distance though? Do we know a distance? Well, let's see. If you're running a race that faster, you can finish the last 3 miles. Okay, that is a distance, and that is the distance we're dealing with. So D is going to be replaced with 3. That's equal to the rate. All right, and again, what is your current rate? Well, we don't know, but we do know that if you take it, and again, we don't know exactly what it is, it's x, and if we add to it 1, that would be the speed that would help you finish those last 3 miles in a half hour. Okay, because it says if you run 1 mile per hour faster than your current speed, so that's x, and then we add 1 to make it 1 mile per hour faster, we'll finish that last 3 miles in a half hour. Now, time. What about time? What's the time we know? Right there, 0.5. Okay, so here's our setup. But what are we going to do with it? Well, we can use the distributive property to help us solve for that variable x. Okay, what I like to do is usually rewrite these as 0.5 and then put the parentheses on the other side. It's totally illegal and fine to do that. All right, and now what do? Well, I'm going to distribute 0.5 to x. So we have 3 equals 0.5 times x is just 0.5x. 0.5 times 1 is 0.5. So what do I do next? Well, got to get rid of the addition or subtraction of numbers or constants first. So I'm going to subtract 0.5 to make that 0. But I have to subtract 0.5 over here. 3 minus 0.5, 3 minus a half is just 2.5. And that equals 0.5 or 1/2 x, because those have canceled. Last step, divide by 0.5, divide by 0.5. What is 2.5 divided by 0.5? Well, it's like saying 2.5 divided by 1/2. That's the same as 5 over 2 divided by 1 over 2. 5 over 2, it could keep, change, flip. So that gets you 5 times 2 is 10 over 2. 10 divided by 2, of course, is 5. So here, those cancel or both become 1s. You get x to equal 2.5 divided by, that's a 0.5, not a negative 5, sorry guys. What does that equal? 5. Okay, so what is 5 though? Well, 5 equals x. So whatever x stood for up here, we can now replace with a 5, right? So x was the current speed. So how fast are you going right now? 5 miles an hour. And if we up that and you increase your speed by 1 mile per hour and now you're going 6 miles an hour, you will then finish the last 3 miles in 1/2 of an hour. So there you go, guys. That's all I have for you. I'll see you in class.